Today we're going to solve for linear systems, and we're going to also determine the number of solutions. If you recall, when I'm solving for linear systems, I have a graph. And on your graph, you will have linear lines. And those linear lines can hit anywhere, and we call that the POI, or the point of intersect. But is there ever cases where we don't have an answer? In this case, you'll only have one answer. But we can have one answer, or we could have no answers. Or we could have an infinite number of answers. And that's what we're going to be looking at today. It's the number of solutions for our problems. Let's do a couple of examples to give you a point what I'm meaning. Okay, let's say we're solving for y is equal to 2x plus 1 and y is equal to negative x plus 7. And I want to solve this. So this is example number 1. How many solutions do I have? You could solve this using elimination or substitution. So let's try with let's do with the elimination. So if I multiply these two out, I'm going to multiply it by 2. So I have y is equal to 2x plus 1. We have 2y is equal to negative 2x plus 14. I'm going to add them up. 3y is equal to 15. Y is equal to 5. Then we can find out what x is. So I'm going to put 5 into here. We're going to have 5 is equal to negative x plus 7. X is equal to negative 2, easy minus, and then divided by negative 1. X is equal to 2. So the POI in this case is 5, 2. And you could solve this using math, or you could actually have a graph. My graph, for example, number 1, if I were to graph it out, my y-intercept is 1, and my slope is 2. That means you go up 2 and over 1. So my first graph looks like this. My first line. My second line is I start at positive 7, but I have a slope of negative 1 over 1. And that's what the actual graphs look like. We can call this equation A and equation B. We have A and B. And the point is 5, 2. In this case, we have one solution. We have one solution. But this is not always the case. Let's do another example. Yeah? Where's 2.5? Oh, thank you. Thank you. This should be the other way. This is 5, 2. Oh, no, sorry, 2, 5. X first. 2, 5. Thank you. 2, 5. For example number 2, let's have a try. We have negative 3y is equal to 5 minus 2x. Then we have 4x minus 1 is equal to 6y. How many solutions do I have? Okay, now you could use elimination or what have you. We can rearrange my equation. So I'm going to rearrange this. So we have negative 3y is equal to 5 minus 2x. And then I'm going to move this over here. So this is 6y is equal to minus 1 plus 4x. I can multiply the top by 2 to get the y's the same. So I have negative 6y is equal to 10 minus 4x. And then I have 6y is equal to negative 1 plus 4x. Now, if I add this, tell me what happens. Look at this. We get 0y here. And if I add this together, this is negative 4x and this is plus 4x, we get 0x. If I get 0, 0, what does this mean? How many solution? What does this mean? It means that there's no solutions. If I get 0y and 0x, it means there's no solutions. If I were to graph this, what would it look like? Why do we have no solutions? Well, yeah, the two lines are parallel. Here's A and B. If the two lines are parallel, it means they will never hit. Therefore, no solutions. The characteristics of this are the slopes are the same. Okay? The y-intercepts are different. This is the key information here. The same for this one. We have y-intercepts are different, and the slopes are opposite. One is positive and one is negative. If you have a slope that one is positive and negative, you're guaranteed to hit each other sometime. Okay? Now the third option, we have one. This has one solution. This has 0 solutions. The last one we have is called infinite solution. So let's have a look at that. We have example number 3. 4x minus 2y is equal to 6. And then we have 6x is equal to 9 plus 3y. Okay, I'm going to move my y's on the one side and move my x's on the other side. So I have negative 2y is equal to negative 4x plus 6. And then on the bottom here, I'm going to move this so I have 3y is equal to 6x minus 9. To get them the same, I can multiply this by 3 and this by 2. So my new equations then are, let me move it up over here. We have negative 6y, negative 12x, and then plus 18. And then we have 6y plus 12x minus 18. What do you notice about these two equations? What do you notice about these two equations? This all has negatives. And if I divide all this by -1, if I divide it by -1, they are in fact the same equation. So this one right here, if I divide this all by -1, we're going to get 6y is equal to plus 12x minus 18. They're the same. Agree or disagree? They're exactly the same equation. If my two equations are the same, it means that you have infinite number of solutions. My equations are exactly the same. So if I were to make a graph, what it would look like is this. My two lines, my two equations, my two linear equations there are on top of each other. So this case will happen, it'll have, both equations have the same y-intercept. And if they have the same slope, it means that you have infinite solutions. You have infinite solutions there. Okay, that's all the cases. Let's go through it. You can have one solution if you have different y-intercepts, opposite slopes. For example, one slope is positive, one slope is negative. You can also have both positive as well, but they have different slopes. They're opposite or different. In this case, if the slopes are the same and we have different y-intercepts, it means that you'll have no solutions. And the third one is if the y-intercept is the same and the slopes are the same, so we have infinite number of solutions.